We are going to talk about monitoring pipelines now. Russ is about to commit an update to our application.
Done.
Cool. And while that builds, let's talk about monitoring our pipelines. I have a question for you, Russ. As a team, why would we want to monitor our pipeline?
So ideally, a pipeline would complete in 15 minutes or less. During that time, I might turn my attention away to another task. And I really want to know if I've broken the build. Having a visual indicator like a light in the office would be pretty cool. A broken build means now we have code in our repository that's not in a good state. I don't want my coworkers pulling down the same code and impacting their productivity. Everywhere I've worked, a fix to a broken build is very high priority. A lot of what we do with DevOps is to catch errors early in the process. The earlier we fix problems, the easier they are to fix.
I see. And what sort of things could go wrong? And what sort of things could break the build?
Yeah, usually I've forgotten something. We're doing two types of testing here. We're unit testing against some mocks, and we're doing acceptance tests that are performing more of an end-to-end test. That's a closer simulation to what we will have in production. I could have forgotten to include a file in my commit. Maybe I'm running a different version of a library on my dev environment. I could be writing code that expects something to be present in the database, and I forgot to include the script that migrates the database. These are all classic, it works on my machine scenarios. When tests run in code build, we're provisioning a clean container for every run of the test. They're no longer just running on my laptop. The fact that we're running the tests on a clean environment means we'll catch the things that I've forgotten. I like that the tests are run in an environment pretty similar to what we will have in production. It's much better to know about these errors before we roll the code to production.
I see. And usually, how do team members react when someone breaks the build?
So in my previous job, we had to wear a funny hat if we broke the build. But breaking the build shouldn't be a big deal. Everyone on the team knows that we want to catch the bugs early. So the tests exist for a reason. I want to know if I've broken something or I've committed some code that's no longer compiling. And that's exactly why we are setting up these processes to know about them early.
I see. And how would you fix a broken build?
So if the fix is going to take a while, I can always revert the commit. I've just pushed something out to Git, and I can roll it back to a state where we know it was good. We know which commit created a successful build, so we can just revert my work and push that out to the repository. To fix something, I really need to know what went wrong. Sometimes it's an obvious, I know what I did, I forgot to include a file, for example. Other times I need to jump out onto the build box and pull in the log of the failure. And code build gives us that. So I can, from the pipeline, I can launch out into code build, and that is writing the logs of everything that happened in my tests out to CloudWatch logs.
I see. Yeah, and the CloudWatch logs can actually integrate with Elasticsearch and Kibana, and you can actually see what's going on under the code pipeline perspective as well.
Sure, yeah.
Right? And this, as you mentioned before, these lights are very interesting because it brings you back to, hey, pay attention because the build failed, and we don't want other developers or other DevOps. Whoa.
What just happened?
I think it just broke.
I think I just broke the build, Raf.
Yeah. So
how about
I
fix that right now? So I'm going to revert my commit that I just did. Git push origin dev.
Cool.
So that just rolled back everything that I did earlier.
Nice.
We pushed that. It's going to go out to our pipeline, and we will see the pipeline kick off again. And hopefully I've fixed the build. I don't want to have to wear that hat.
Yeah. And you can actually see the value proposition of infrastructure as code because what you did there was a Git revert. So you actually reverted the infrastructure. That could be the CloudFormation template, or actually in this case it is the application. It actually reverted to the previous state.
Yeah, we call that treating our infrastructure as code.
Yeah. And then you can have everything on this code commit repository, both your CloudFormation templates and your application. You could do different stacks for that. You could put on the same stack, but that's actually a very good value proposition of cloud computing and being able to execute everything programmatically.
Sure, and it's a very nice way to work. That's a preferred way I would work, actually.
Yeah, yeah. Now it's in progress again because you just checked, you just did check-in in the repository. So CodePipeline detected that it was a new push on the Git repository caused by your Git revert.
Mm-hmm.
And then it's triggering the pipeline, the continuous integration pipeline again.
Mm-hmm.
So it's now on the source state.
Mm-hmm.
Then it will get the source and build it. And eventually that could deploy into production.
Sure thing. This is the continuous integration phase of our pipeline.
Yeah.
That a commit is pulled into the pipeline, we're building it, maybe it's Java code and we need to compile. That would detect maybe a syntax error in my code. In this case, it's Python. I actually removed a library that we were using in the tests, and we got immediate feedback from the pipeline.
I see. Now the source phase succeeded. It should be starting the build. And then when the build succeed, we should see the green light again, telling that the build succeed. But that could actually be extended to the continuous delivery and even the continuous deployment stage, where authorized developers or DevOps administrators could do a search and push with a specific tag. And if that developer does that commit with that tag, then it's a signal that this one should be moved to production. So it's very interesting. If you are curious to know how the light bulb works, check out the following segment. This is the hardware you're going to need to achieve that. You will need an RGB light bulb where you can programmatically change the behavior, and a computer to run the code that will do that. Here in the studio, we are using a Raspberry Pi to run the code. In that way, the application continues running even when I'm not here with my laptop. There are plenty of these IoT light bulbs nowadays, and many open source projects that allow you to programmatically control them. The best part is that it doesn't require any soldering expertise. Once you have these components working in your Wi-Fi network, it's time to move to the AWS configuration. All you need to do in the AWS account is configure CloudWatch events to put a message into an SQS queue whenever there is CodePipeline activity. You can literally configure that in 10 seconds in the AWS Management Console. This will put messages in the queue whenever there is activity in the CodePipeline. The messages will be JSON arrays containing information about the stages of the pipeline. Once you have both the hardware and the AWS services configured, it's time to write an application in the Raspberry Pi that simply gets messages from the queue, parse them, check the message content, and take an action. In this case, I'm changing the light bulb color and displaying a message on the screen according to the pipeline status. Although it is pretty easy to do that, obviously it's not required as part of this course, and we won't have an exercise for that. You could integrate that application with Amazon Chime chat rooms, mobile applications, or anything that your imagination allows.